Um, Good to see all of you. I didn't know what kind of audience to expect, so some of the slides I'm going to go through quickly because I know that you don't need to hear them. I know who you are. So Tim gave you a quick rundown on who I am. So I'm a big believer in credentials, and you never know when those credentials are going to help you, but you want to get them and you want to use them. And you can see after my name, I always put the comma PE. 95% of people in higher education have no idea what that is. But that's all right. They might search or they might look. And I put it on my business card. You know, it's part of me. And I'm going to encourage all of you to look that way. You're a little bit away from that, but you could be, some of you could be thinking FE now, Fundamentals of Engineering. It's still called that. It was called EIT, Engineering Training. When we did it, I took that my senior year of college. Took that exam. For us, it was half a day, bring in whatever books you want. So like people brought wheelbarrows, literally filled with books. No, I just took 2 backpacks and took them into the classroom. And it was, I mean, there was physics on it, there was fluids on it, there was thermo on it. A lot of the courses well, again, you're not mining engineer, but in your field. Well, and it's the same for all disciplines.
It's pretty broad.
Electricity's on it, but you should go that way. So Tim mentioned my engineering background. You know, maybe, again, I thought maybe we're freshmen and we're still deciding on engineering, but some of this I have in there. I just knew from high school that I liked math and I wanted to go into a field that was like my best subject in high school. And my father was a mining engineer, which was surprising. He's still living, he's 92 years old, but he was in World War II, came out and used the GI Bill to go back and be a mining engineer. And like, I'm thinking, what do I want to do? Well, there are mines around here. I can get a job. I'll be a mining engineer. It probably wasn't the best career choice. Like, I wasn't challenged by my high school guidance counselor. Engineering was a good choice. I didn't know how limited and specialized mining engineering was, though. And, I'll tell you more about that. Well, I mean, maybe I've just mentioned it now. So I worked for 4 years, but the mining industry kind of goes with the price of energy. And the price of coal went from about then $50 a ton down to $30 a ton. And all of a sudden, and they always told us at Bethlehem Steel, right here in Evansburg, Bethlehem Mines, we had the best coal in the world for making steel. And that they never shut us down. And Bethlehem Steel was the largest or second largest steel corporation than either U.S. Steel or us. But 4 years in, I'm out of work. So I was so glad I had started my MBA already, and I got that experience. That's why I might have considered environmental engineering or civil or mechanical if I knew that then. But I still wanted to stay in this area, and I said, what can I do? I actually came back to St. Francis to be a math teacher, and I got certified. I taught at Central Cambria High School for half a year, but St. Francis offered me a job because I had also been working on my MBA at the time. So I had a master's degree, I had an engineering degree. They said, come and run our labs and teach the one physics course we have, okay, and the one engineering course, and run our engineering 3-2 program. So I did that. And while I was here, I kept working on degrees. I actually came here to work. I had my MBA started when I was at Bethlehem. You know, just a year into Bethlehem, I saw in the employee handbook, it's free to take courses. I'm like, oh gee, I can make more money, kind of, like more benefit. Why wouldn't I do it? And when you get your job, your companies will have tuition remission, it's called. Yeah, take advantage of it. Use it. And each of those credentials helped me, I think, along the way. Probably because I had the master's degree, I got the job here, I told you I came back to be a teacher. That's why I completed my Master's of Education. And then probably for convenience, things are different today. You can get almost any degree online without being a full-time student, but then you couldn't. And I had to be local, so I went and got an education doctorate. I'll talk through some of those experiences, especially the Bethlehem one, because it was my engineering, a little bit of the NASA one, because it was my engineering. I was ready to talk about why you should get a college degree a little bit. You make $17,000 more on average a year with a college degree than a high school degree. Over a lifetime of earnings, that's like $1 million, and you can see it kind of jumps up with your level of education, so I'm a big believer in that. And I don't have to tell most of you that it's not automatic. It's like to earn more, you better learn more is kind of the rule of thumb. And again, I took from I thought you would be a lot of freshmen and I'd be inspiring you to work a little bit harder. I just gave the test and you know how it is. They don't do as well as I want them to do. But these are the 3 things you can do to learn more, to earn more. The research says if you want to live with your parents, not have a job, smoke cigarettes, not read the newspaper, all of those things, don't get a college degree. And if you want to get a college degree and make a difference, be successful, like not live with your parents, not have debt, not smoke, get a college degree and make it work. And the 3 things that you have to study alone, the more you study, the more you learn. That's easy. If your teachers have high expectations, so the teacher you think that's hardest here, that's really making you work the most, they're probably helping you earn the most too. And your courses have rigor, so when there's 25 homework problems in a chapter, that's not like for our benefit, that's for your benefit. And again, enough said. I know you're successful students, I don't have to tell you that. And one more thing. So how much time do college students study? Here's half of your wakeful week, or your living week. You spend 51% of your time socializing. I know you don't. You don't. You can't, because you have to spend more time studying than 12 hours a week. Do you? 12 hours a week is the study piece of that pie. 12 hours a week, that's like 2 hours a day. Do you spend more than 2 hours a day studying? Okay, then we're good there. That 1 million isn't automatic, and it's not the same for all disciplines. And the good news is, you're in STEM fields. And STEM, top paying college, 3.4 million over a lifetime than the lowest paying. This is Georgetown Workforce and Education. So some fields pay a lot more. Not surprisingly, STEM majors, science, technology, engineering, math. Those that can do math, basically. You can't have any of these jobs. My definition of an engineer is a technical problem solver. And I tell students, you don't have to like math, but you have to be able to do it. I've seen a lot of engineers come through who really like getting their hands dirty and working on things and can see things working in their mind. Visualization skills, that's all good. But if you can't do calculus and differential equations, it's not going to succeed. But anyway, almost all the highest paying fields. Again, they get paid more than PAs and PTs. They have to go 5 and 6 years to school, and they only start at 70-ish. And then 80 maybe, and they don't advance much. Accountants, yeah, they get up there too, but a 4-year degree, engineering's the best. Money-wise, money's not everything, but it's a big part of it. Mid-career earnings of $136,000. And there's good outlook. What does it say? Increase of 13% of accountants and auditors, other high field, STEM fields. This was too general. I should have focused more on engineering there. I always do a career comparison. Where do they sit? You can see the heavy ones on the left: data science, statistician, mathematician. First engineer is software engineer. That's more computer-ish. There's 20 is petroleum. This is out of 200 jobs, not just rated on salary, but salary, stress, outlook, work conditions. let's see, are there more engineers? Yeah, there's environmental, 37 out of 200. Pretty good career. Civil, university professor right in there. Yeah, you know what, university professor? I don't know professors, if you would agree with this. We're at the top of the list of those 5 factors. Did you hear them? Salary, work conditions, stress, outlook. Well, maybe there's only 4. College professors at the top of that list then, not salary. Stress. We're the lowest stress job there is. College professor. Does that make sense? Like, we're under deadlines, we have to publish, we have to get promotion, tenure. I don't know. Computer programmer, chemist. And I always like to show the bottom of the list where you don't want to be. You don't want to be a newspaper reporter because there's prints going away. You don't want to be a logger. It's dangerous. Police officer, you're getting shot at. Architect, kind of low. I don't So let's focus a little bit more on mining engineering. And again, I'm not here to sell you on mining engineering. I'm here to tell you a little bit about it. And I just went on the internet. You know, they're working with minerals and energy resources. And I was focused on coal. It was coal mining that I did. My roommate ended up going to Peru and Arizona and Colorado and working for a copper company, though. It wasn't all coal. The majority of us, we were in Pennsylvania. What's in Pennsylvania mostly is just coal. And that's why most of us did coal, but again, he went and traveled and did others. We did go into a limestone mine. That was really freaky. I'll talk to you about our mine. Our mines are, you know, our mines, if it was 5 foot tall, that was a high mine. Because you go in where the seam of coal runs through the ground, and you cut the coal out, and then you walk through the hallway that you made. And if you take more than the coal, you're taking rock, which it's real easy to cut coal. It's like slicing through warm butter, but it's really hard to cut rock. It's like trying to cut a rock with a knife instead of warm butter. And it also costs a lot. It pounds your equipment. It makes a lot of dust. You have to store what you cut. So you don't want to cut coal. So you put hats on like this, not just to protect you from things falling, but so, and I'm 6 foot. So a lot of the miners that were good at it were a lot shorter. But you're wrapping your head on the ceiling almost everywhere you go. By the way, the Bethlehem Mine sticker, they don't exist anymore. The company went bankrupt. They did last a few years after me. Bethlehem, Pennsylvania has a nice museum if you ever want to go that way. Of course, you put some safety tape on because you wear a light right here on your hat that shines wherever you're looking, but the safety, you could see people real quick with the reflective tape. And notice how neatly it's cut, because as a young engineer, you have a lot of time to just sit in your office and do nothing. So you get different colors, and you cut them and trim them real nicely. And by the way, you're a white hat. It wasn't easy being a young engineer. Like here you are 21-ish, 22, you graduate, and all of a sudden you're a white hat, which means you're not union. You're in a mine with 700 people, and there's only 10 who are company white hats, and you don't know anything. It was a tough environment. Yeah, tough environment. Courses, well, it's similar to what you've taken. You take thermo, you take fluids, right? You don't take an entire electricity course, though, do you? General will. You don't take the FE. I swear there's some electrical on that, but maybe it's simple enough that you learned in physics. I kind of don't remember. And there's some of our other courses. Some of the experiential courses, when I heard the geology trip, yeah, we took geology courses, and we'd go down along 322 below State College. I went to Penn State, and we'd see the geology there in the mines, because they have to cut through for the high, or on the the highway, along the highway, because they had to cut through and expose all that rock so you could get a good look at it and understand the geology better. One of our classrooms was a wind tunnel built underneath that we would go down and measure with an anemometer the speed of the air flowing through and then try to measure resistance and the rest. We went to underground coal mines, we went to surface coal mines. Our senior design project, we had to design our own mine. We had to locate a property of land, and mine was in Illinois, I think Carbondale County, I don't know why I remember that from 40 years ago. But then I had to go and find who owned the property and propose to buy it and propose the type of mine I had to create. And I mean, it was like a 100-page document by the end, and that was largely done by hand. We weren't doing much with computers then. Back to it a little bit. When I started, I don't even know, have you ever seen a slide rule?
Yeah.
This is how they did their math, their addition, subtraction, multiplication, division, their logarithms, their exponents. You line up the sliding one. Honestly, I might, if I sat for a few minutes, I could probably figure out how to multiply 2 times 3 to get 6, only because I know the answer. But like this was 1979, and we were the first year that didn't have to use them. They let us, calculators had just come out, so I went and bought a $200 Texas Instrument, and it was like, oh my God, look what it does! And we don't have to use that. And we use scales, engineer scale, architect scales. We had to draw a lot. You're doing all of that online. It's a lot easier than it was then. So, some of you are just along the way now. As I'm in college, one of the first things I did is I tried to have a summer job. And the summer job at Bethlehem Steel, Bethlehem Mines Corporation, so I graduated in '79. This was my summer assignment. I'm reporting on May 30th. What they have me do, they spend time with the surveyors. And oh, by the way, when you end up getting a job like that, you do everything that they do. Like when in Rome, do as the Romans. The surveyors, the shift started at 7, but they didn't really start working till like 9-ish. First stop was Keystone Truck Stop, right out here by Munster. And I had to learn to drink coffee. I hated coffee, but I'm like, I can't drink chocolate milk. They went and sat and drank coffee for 2 hours. You do what they do. And that was good to learn and be with that kind of person. So I don't know, when I'm teaching some of you, I'm always asking, what are you doing for the summer? You ought to be trying to get jobs in your field so that you get experiences. And I know environmental, you have to do internships, right? They're valuable. So I did that in the summer, and oh, by the way, then they hired me. I think that kind of followed right along. What at least the first thing you do when you get to Bethlehem, again, they don't exist anymore, is you go through a loop course, a year-long leadership training program. They took us to Bethlehem, Pennsylvania. You know your way around out there, Brother Mary? There's an 18-story building that sticks out of the landscape. It's called Martin Tower. It was Bethlehem's building, because Bethlehem Steel started in Bethlehem, Pennsylvania. They had us there for 2 weeks. And then they sent us back and kind of visit each facility. I think we had 11 mines. I spent at least part of my time at each one of them. This is kind of in the book that they gave us, that's what a mining engineering looks like. Well, I guess it's, you have your mining equipment, but you're also in the office some. What was my job like? I think a lot of what as I look back on it, you're only 23, 24 at that point. You don't get to do a lot of things. A time study is more of an industrial engineering kind of duty, and that's what I did, some of it, and I still have some of that. So that was a time study, only 2 shifts. That's unusual, because I thought we always went in for a full week. And well, you can see we didn't have computers to type these things, so you printed as neatly as you could, and go ahead, Ron.
Did you have to go through a general printing class? Like, I know that my
You
dad
took
said-
engineering graphics? Yes. And the first assignment was, here's the letters of the alphabet, and make 10 of them.
Yeah.
And here's the numbers, and make 10 of them. And your E couldn't be, you had to there's your large E, and here's your small E. Make them all look like you're supposed to, I'm glad you don't have to do that anymore. But just like your project reports, you give an introduction, you tell them what you're going to do, you gather some data and you present it in some way. I mean, so a time study, it took 90 minutes. Wow, you're only on an 8-hour shift. So it took an hour and a half of that just in and out. Well, this mine 33, and it's right over here, like you take Manor Drive to Evansburg, you see Lake Rowena. Off to the left, you see some smokestacks sometimes. Those are cogen plants now where they're burning our waste coal. That was where the biggest mine was. There was also one along Manor Drive about halfway, Winterset. But this was the largest one. It was like a city underground. There were 1,100 people working in that mine. And 3 shifts a day, 360. They worked more than sheets. Well, I shouldn't say that. They did shut down. And this was an interesting experience. One of the crews, you know what? It might have been this one. I saw Gary Scott. We might only gotten in 2 days, 2 shifts that week because they had a fatality. So it wasn't my shift. I probably was daylight. I think it was second shift. And a miner got pinned up against the wall by a piece of equipment and died. And I showed up the next morning to work, and there's a sign saying no work. And I'm like, I don't know what this means, no work. So I go in and ask, and they said, yes, there was a fatality, so they closed the mine for 24 hours so the miners can grieve and so that they can do a safety analysis, what caused the accident. So that could have been why. But like I said, it was like a city down there. The first thing you did is you went down an elevator 1,000 feet, got into, was like a train car, and sat there for at least 30 minutes to get there, and then you had a long walk to get to your face. So a lot of it's just in and out. Where did we actually load coal? 270 minutes. We were actually cutting coal and loading it onto cars out of a shift of, so only a third of the time. And the purpose of doing a study like this is then you go outside and you show this to the mine foreman, and he says, what the hell? You mean they only mine? Is that 270 or 210? They only mined 270 minutes? What were they doing? Lunch sometimes would stretch, and they didn't like that. They wanted production, they wanted coal. Oh wait, that travel in that's an hour and a half in, an hour and a half out. It wasn't the most efficient mine. If you look at it that way. And you also give a percentage breakdown. And so then you also show what you did. So this is a mine map. I don't know if you've ever seen any. So these are kind of the tunnels this is coal. And again, it's like this. And then you take piece by piece 20 feet. Why only 20 feet? Because if you go more than that, and you're sitting at the back of the machine that's mining the coal, if you only go 20 feet, you're not under the part of the roof that's not supported. So you go in and you take 20 feet, then you go over here and mine somewhere else, and another crew of 2 people come in and support the roof. And then you come back and you cut more of it. So piece by piece, you advance all through the mine. And then, oh, by the way, once you get the 4 headings, the 4 tunnels cut, then you do cross cuts. And you need cross cuts because, for several reasons, this arrow shows the clean air coming in, and it would come up, and probably up and around here, and then here's the dirty air going out. And you kind of have to keep them separated. Even though you cut a tunnel through there, you come back and you put a brick wall up. You have masons as part of each crew of miners. This one is a belt line. It's a conveyor belt, and right here would be a place that, I don't know, cut bottom. Ooh, that's bad. Cut bottom is when they're digging rock. And there must have been a reason they did it, and that slows production, and we can't sell rock. But anyway, that's a mine map. And then, so surveyors come in and document all that, and then they go out and they draw the big mine map. And I'll pass two around. This one shows those same tunnels being drawn. And this was a longwall mine. In between two sets of those tunnels, about 500 feet wide, they take every ounce of coal. And it kind of caves in underneath it, and that's a longwall mine. This one's a room and pillar mine. You're going to see a lot more of those tunnels, like they're kind of everywhere. You still try to get every ounce of coal that's in there, but that room and pillar mining is kind of scary, because let's say this is all the further we were going to mine. We're done going in that direction, and then we start doing retreat mining, and we try, what ends up left here, these blocks that look real nice and rectangular, are the supports. Yeah, there's rock above the coal, but we've cut out the coal, so there's nothing to hold it up. Yeah, we put bolts up into the roof to try to connect the layers above, but these are still pillars of coal that are supporting all that roof that's up there. But when you room and pillar mine, you start cutting off pieces of the pillars, and you watch for things to break, and you have wooden timbers, and when you see them compressing or hear them compressing, you know it's almost time to back up. And I was kind of jitterish. I'm saying, like, guys, we got to get out of here. And they're not, no. Because what ends up happening is if it doesn't cave right, it builds up too much stress. These pillars are holding too much of the rock and probably getting too deep. But anyway, that's a little bit of what I did as a mining engineer. Do you kind of have questions there along the way? That was mostly, I mean, you had to have a knowledge of mining, but it was mostly industrial engineering type of duties. Oh, and then the report continues. Why was there breakdown? They want to know that. What else did they want to know? Oh, finally, recommendations. Both shuttle cars, because the cars took the coal away from the continuous miner and put it on the conveyor belt. Should be used whenever possible. I thought that both could have been used while taking bottom in the track entry. This would have helped because the shuttle car used was side dumping and had to do so slowly because it was hauling rock, substantial. You know, and again, I'm a 21-year-old, am I able to make those recommendations? Yeah, well, I'd try to talk to the guys and they'd say, I don't know why the hell the other shuttle car operator's down in the lunchroom for 2 hours. So I'd write up something. So anyway, I get laid off. Come to St. Francis University. Here, I'll pass this around for Bethlehem too. We had to keep daily logs of what we did, all pencil, but you had to be able to show what you did. So come to St. Francis and end up getting a job, but I still want to use my engineering career. Well, you take the engineering training. To sit for your professional engineer's license, you need 5 years experience?
5 years. It's 5 years experience, but if you are in graduate, we had talked about this, when you're in graduate school, I think 1 degree is like 1 degree counts for a year of experience, or 2 degrees of something like that.
So I had 3.5 years with Bethlehem, and I'm thinking, oh, I want to get a credential like that, and I want to use it because I think I could pass exams, I could study and I could learn. Well, after I left Bethlehem and I started thinking about it, you have to have documented your experience. So I went back to Bethlehem, and it has to be documented by a professional engineer. Well, I forget who signed this, I cut that off because I was trying to show you. But they documented my experience. So I had 3 months one summer, 3 months another summer, and then I had, oh, that's wrong. I didn't start until '79. Yeah, even the dates overlap. Oh my God, how did I get my professional license? The date's wrong on the source papers. But yeah, it's 79 to 83 would have almost been 4 years. It was 3.5 years. What did I do? A loop year activity, management training, setting sites for laser beam and number 2 Air Force. I hope I did more than that. Computer simulation, yeah. Getting air to, mining coal generates a lot of dust, which is dangerous to the workers, and of course you can't see, so you need to have air going, so you need to build fans and push the air or pull the air. Anyway, that was a big one. Did time studies, tunnel liner and arch installations, implementation, yeah, statistical analysis tool, that was funny. So the toughest job at a mine was the mine supervisor or foreman. They'd go in with a group of 10 people. They had to be there like 2 hours before to set everything up. Then they'd be underground for 8 hours. Then they'd come out of the mine and have reports to complete. And Bethlehem wanted them to go to a computer and type in how many tons of coal I loaded. So I had to train them to use this system. And like, okay, the guy comes and I says, okay, type in your name. And like he's saying to me, where's the F? I'm like, oh my God, you know, how's he gonna, computers were kind of new. They were trying to use a system that didn't fit the people. And these guys' fingers, because they're like, they work underground, they're manual laborers, their fingers are bigger than the keys. So they would finally find the F and they'd touch it and they'd hit 5 keys and they didn't know why it wouldn't work. And probably the same things when you're trying to teach your parents how to use a cell phone kind of thing. I needed more experience, and I was a young faculty member at St. Francis. So I went to NASA, Langley Research Center. I applied for a fellowship, a summer fellowship. And what I did there, so what their problem was, they were just getting into printing computer documents, like these maps, but I mean, they were worried about flight, not mining. Instead of drawing them and having one source document, they were able to change them on their computer and print them, and they couldn't control them. They didn't know which one was current. So I went there and I studied their process and made a flow chart and made recommendations. And you know, what it gave me is 4 more months of mining experience so that I could sit for my PE. And my PE, now that fundamentals of engineering is the same for every engineer, but I think the professional engineer is based in your discipline. Is that right? Because
yes.
we took one that was just mining. I was sitting with mechanical engineers in the same building, but they were taking a different exam. And that one, as I recall, was 2 days long. I mean, it was just exhausting, but it was well worth it. I mean, no one's ever going to take that away from you. And you can see I got it in 1986, so I started here in '83. So I was 2 or 3 years in here, and I used my faculty experience. I went to the physical plant. Our director of the physical plant was a professional engineer, so he was able to sign for me. And that 2 years in NASA and then the Bethlehem time. So what do I get out of it? One thing is I get a stamp. We actually have to buy the stamp, but
Get the access.
you know, so like if you need an engineering document, I want to look over it, make sure that it meets all the standards. And you know, I really, here at St. Francis, I've used it for decoration a few times, but I've never approved an engineering document. I'm not, I mean, that's kind of not my job. But I think it's helped. I don't know, maybe when I went up for promotion or tenure, they said, oh, he's a registered professional engineer. That's kind of like being a CPA. That's like recognized as high in your profession as you can be. So again, get all the credentials you can, is my advice. And you know, otherwise, that's kind of all that I had for you today. Again, I didn't know what audience you'd be. I'm glad that I got the chance to talk though, because when I came to St. Francis, we had a 3-2 engineering program. Engineering statics and dynamics was the highest level course we had. I never thought we would have a 4-year engineering program. And then I never thought it's going to be ABET accredited. Oh my God, St. Francis? You know, we're kind of the tiny engine that could. And it always hurts a little bit that I was never involved in that, but I've gotten so much involved in administration. I just teach the one course each semester. I think my MBA kind of pushed me more that direction, that I had that management, finance, accounting background that I kind of learned to manage more than I did practice engineering. And I've been doing that now. I've been at St. Francis 35 years. I've been doing the administrative role for 27 of those 35 years. So, but I'm so glad to have engineers here. And even though a lot of my presentation wasn't really set real well for you, I can fine tune this if I do it every year. If Tim would have me back next year again, I'd love to do it, and I'll try to target it a little bit more for you. I hope you have some questions though.
I really like what you said about, from the point of view of getting experience you needed to get your, to be able to sit for your PE license, right? The way it works is you pass the EIT or the Fundamentals Engineering exam, but then it's 5 years that you're working, but you have to be supervised or in association with the PE, and then you sit and take the PE exam after that. And I think I had to get like 3 letters too. I think from
Yeah, it's at least
PE
3, and it needs to document all your time. I recall.
Yeah, but the thing was, and there are many other things that are like that too. Is sometimes you don't have the opportunity to maybe do it in one grand sweep, but the ability to keep track of when you did stuff, do things during the summer, those types of opportunities are things that add up and enable you to fulfill the requirements. Sometimes people don't realize that, and they do a summer job and then they, oh well, okay. But if you keep that in mind, you don't have to go back and ask somebody to screw up the dates on your.
I mean, and save your artifacts as you go along. I mean, this was the book they gave us here, Welcome to the Loop program. Definitely Steele. And I mean, I have the original letters of most of the work I've done, including like when I was summer. And I still have, I go back and look at my physics notebook from when I took it as a student. The exams they used were Blue Book. I remember what's crazy about Blue Books. I think they were better for history courses, rating text than it was. I loved using engineering paper. I don't, do you use that much around here? The kind of the green with, you don't see the lines on the front of the page or when it's supposed to. Well, that's what you saw those that I projected up there. It looked like the freehand. No. You used the paper that had the lines kind of behind it. Well, you do so much by print now.
Sean, this is curious. Because you talked about maybe your MBA kind of pushed you down one track. Do you see us getting? Did you see the additional degrees and credentials more of opening doors for you, or really more railroad you down a certain track? Or how do you see that playing?
You know, there's 3 young computer science majors. They're not young anymore. They're in their mid-30s. They've been 10, 15 years at CTC in Johnstown, and they know all of them. And CTC is a grant-funded organization. It'll go away someday. And I've been saying to them, get your master's degree, it's free. And like, I don't know what the master's would have done for me at Bethlehem, but as soon as I got laid off work, I was kind of a step ahead, and it prepared me for something I didn't even know that was coming. Like a master's degree meant you could teach at a college. So I don't know if I answered your question. I'm so upset that those students, and I'm trying to get them into our MBA program too, because we teach courses at CTC in Johnstown. And I'm like, why wouldn't you? It's free, or you're getting paid more. There's two ways to look at it. Either you're getting the degree free, or actually now they put it on your W-2. You have to pay taxes on some of that free tuition you got, so it's like more earnings. But you got paid more than the person who didn't take a course. Hey, that's great. And you learned, and it helps you down the way. By the way, so you're thinking of how you sit, and are you prepared to go out and work in the real world? I always considered myself an average engineer. I was like 3.3, 4 grade point average. You know, the smart ones are, I made Dean's List once or twice, but I wasn't blowing the world off. But go into some of those other fields, like business and education, I think that's one reason I kind of liked it, because you're a genius when you get into those fields. Like you already can, they'd say, you could do all those numbers in your head. And I'm like, well, yeah, because that's all we ever did. But it's your logical thinking process too. You're developing skills that'll carry you into those other fields. Like, I could never have been a teacher, I thought, when I was in high school. I did in graduate school, did you do the, the Myers-Briggs personality? Did you do that, Rachel? And it told me I'm an introvert, and introverts aren't going to be teachers. But you know what? If you can make it through thermodynamics, and you can make it through with organic chemistry, and you can do anything. And especially, it's easier to talk to a group when you have something to talk about. If they say talk about friendship, no. Let me talk about how I solved this problem. And so that's my experience. Is like those other fields were so much easier. That's why you think, how can you have a full-time job and take courses? No. Get into a master's degree program. Get a degree and see if you like it. And it doesn't have to be in business. Business is a good general one that will move you in any direction, but get one in environmental engineering. Oh, and then think about staying for the doctorate and be a college professor or that direction.
I really like that because my experience, before, as most of you know, before I came here, I was at Penn State Applied Research Lab, and I managed an organization. And many of the young engineers that came on board with a bachelor's degree, but then they were able to take one course a semester at Penn State and gradually get, the name for them was non-traditional students. And the non-traditional students then would eventually have enough credits to get their master's degree. Some even went off for PhDs.
Did they all do it?
Pardon me?
Did they all do it?
They did all do it, but we encouraged them strongly to do at least the master's degree. Now, PhD was a little bit more difficult because sometimes you had to give them money to support a project. But the master's degree, though, we would often be able to find projects that they could use directly, either for a thesis or if there was a paper option you could do as well. And it took time, but I totally agree that after 4 years, 5 years, it actually kind of goes fast.
Well, it's kind of called lifelong learning. You don't want to stop learning because the more you know, it still holds. And you think once you finish your bachelor's degree, like, I'm done. No, you want to keep learning and get better at your own job. And my first 30 years of being a professional engineer, you didn't have to do anything. You didn't have to learn. But now, every 2 years, we have to have 24 hours professional development. So you go to a conference and you take a session, or you go online and take a 1-hour course and take a test after it to maintain, more like what they do in other professions. Medical fields make you retest. Engineers haven't gotten to that point yet.
Publication gets you 10.
Oh, really?
Yes.
Publication gets you,
10, yeah.
oh man, 10 hours. I didn't even know that. I probably had some that would qualify, but I do I've actually, you learn a little bit on each one you do. I try to pick ones that are more relevant to what I do here, but. Any other questions? Anyone?
One thing you've probably heard this from Mr. Wadle, who talked to us about the professional engineering exam, but just something that is changing kind of as we speak is the FE has always been, well, not always, but has been for a while now, computer-based. The PE, which will take after a few years, is also moving to computer-based, so that would be something to kind of keep your eye on in the next few years as you prepare for it, to kind of learn what are the strategies that help you to be successful on that.
Does that mean like it's kind of all multiple choice?
Yep, it'll all be I think it's all multiple choice now anyway, the PE, but.
So you're not actually writing and
Yeah, it's all.
generating sketches and, because ours was a lot of that.
I mean.
But
not the FE and not-
I think in each session, there were only like 4 or 5 problems. I mean,
Yeah,
very
that's
involved,
changed.
big problems, but they made the point that your logic and setting it up and your system to approach it, your own sketches, could be as important as the answer. You know, whether that was true or not.
Almost like a partial credit type of thing.
Yeah, right.
Because they have professional engineers, in that case, review the problems that you solve.
Right.
They
To look at your process as
Yeah, they
much
look
as.
at them, and so it's, I don't remember too much, I guess I kind of seared that from my memory.
Well, that's interesting. I didn't know that they did go
Yeah, the
on.
other piece that's changing is, so until, I believe it's next April, the PE has been, like he described, where you bring in your own materials, and there will no longer be that option. There will be a handbook that everyone receives.
You know, I was so glad that I did my EIT, your FE